வெல்கம் டு வெற்றி நீட் கேட்வே. இப்போ நம்ம என்ன பார்க்க போகிறோன்னா, நம்மளோட வெற்றி இன்ஸ்டியூட்டோட மாக் டெஸ்ட் அண்ட் ஹிந்து பேப்பர் அண்ட் மக்கள் குரல் நியூஸ் பேப்பர் கொஷின்ஸ்லேருந்து எப்படிலாம் நீட் 2023 கொஷின்ஸ் ரிஃப்ளெக்ட் ஆகிருக்கு அண்ட் நம்ம எப்படி நம்மளோட கொஷின்ஸ் யூஸ் பண்ணி என்ன மாதிரி நம்ம அதை சால்வ் பண்ணலாம் அப்படின்றதையும் நம்ம இப்போ பார்க்கலாம். The first question is, which among the following options is correct graphical representation of Boyle's law? Here this is our Vetri's question. Here we are asking the arrange the temperature in the correct order. This is also by arrange by using the Boyle's law. Here if we draw a line here, we mark this point and this one and this. This is a P3, P2, P1. They increasing. If a pressure increases, temperature also increases according to PV equal to nRT, according to ideal gas equation. When pressure increases, temperature also increases. So P3, which is directly proportional to T1, P2, which is directly proportional to T2, and P1, which is directly proportional to T3. Here the correct order is T1, T2, T3. In neat question, this is the answer. Option 1 is the answer. If we draw a line here, we mark this point and this point and this point. This is P3, P2, P1. Here also when pressure increases, temperature also increases. Here P3, which is directly proportional to T3. So then P2, which is directly proportional to T2, and P1, which is directly proportional to T1. So the correct order is T3 greater than T2 greater than T1. This is the option, correct option. For a certain reaction, the rate which is equal to K concentration of A to the power 2 concentration of B, when the initial concentration of A is tripled, keeping the concentration of B is constant, the initial rate would. This is a neat question. Here the Vetri's question is, for a reaction A plus B gives to product, the rate law is given by the rate equal to K concentration of A the power 3 by 2, the concentration of P the power minus 1. What is the order of the reaction? Here we are asking the order. This is X, this is Y. Here they are asking the concentration. How we can write, no? Rate which is equal to K concentration of A the power 2 concentration of B. In the initial concentration of A is tripled. Here the initial concentration of A is tripled. So 3 power 2 is 9 K concentration of A concentration of B. So the rate which is increased the factor of 9. So the answer is increased by a factor of 9 is the correct answer. The correct order of energies of molecular orbital of N2 molecule. This is a neat question. Vetri's question is, choose the correct bond order for the given molecules, lithium and helium molecule. First we have to know the molecular orbital diagram, then only we can calculate the bond order. So here we are solving we are already practiced this molecular orbital diagram for lithium and helium. Here they are asking in neat questions, they are asking for nitrogen molecule. How can we write? This is an energy diagram for nitrogen. Oneness, sigma oneness, sigma star oneness. Electronic configuration of nitrogen is 1s2, 2s2, 2px, 2py, 2pz, 1, 1, 1. Total 7 electrons. Here 1s, that is a 2 electrons. First we have to fill the 1s orbital, and second we have to draw a 2s orbital. 2s, this is sigma 2s, this is sigma star 2s energy level. Then 2px, 2py, 2pz. Here also 2px, 2py, 2pz. The lower energy is pi 2px, pi 2py. Then sigma 2pz orbital. Then pi star 2px, pi star 2py. The next step is sigma 2z, sigma star 2z. So we have to arrange the energy level is first sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, then pi 2px equal to pi 2py, then sigma 2pz, pi star 2px equal to pi star 2py, then sigma star 2pz. This is the correct energy level of N2 molecules. Here the option 4 is the correct energy order of energies. 1s, sigma star 1s, sigma 2s, sigma star 2s, pi 2px, pi 2py, and sigma 2pz, pi star 2px, pi star 2py, and sigma star 2pz. This is the correct option. The next question is, which complex compound is most stable? Here this is our Vetrii's question. Among the following complex which shows cis and trans isomerism. Here option 1 and 3 which shows a cis and trans isomerism. Among these two, this complex has a more stable when compared to this because it contains a ethylene diamine which is a bidendate ligand. Here similarly when compared to these three complex contains only monodendate ligand. In option 2, this complex only contains a bidendate ligand which shows a more stable when compared these three. So option 2 is the correct. Identify the product in the following reaction. Here they are giving a diazonium chloride which is reacted with cuprous bromide and HBr, and further it is reacted with magnesium and dry ether and followed by hydrolysis. They are asking what is the product. This is our Vetrii's question. Here we are asking the catalyst, which catalyst we used in the diazonium chloride conversion. Here we are using the Cu2H2 cuprous chloride used as a catalyst. So here in the first step it is a diazonium Cl into Cl minus 2 plus Cl minus which is reacted with first cuprous bromide Cu2Br and HBr which gives a bromobenzene. This bromobenzene is further reacted with magnesium and dry ether which gives a Grignard reagent MgBr which is on further hydrolysis we get the product benzene. So here the option 1 is correct.